Levitating Balloons by Group 2B. Throughout this lab, we wanted to find an experimental design that could quantify the charge of two objects. We hypothesized that two balloons charged with the same mechanism would produce charges of the same sign that would result in measurable repulsion. We wanted to quantify the charges of the two balloons. We mainly found that the balloons had equal charges of the same sign, which was determined when they repelled. For this lab, we used two models. First, we used a system schema. As you can see here, balloon 1 and balloon 2 have an electric force acting between them. We used the scale as the ground for this lab, which is in contact with balloon 2 and also applies a gravitational force to balloon 2. Our hand was also in contact with balloon 1. For our free body force diagram, we chose to not include the gravitational force that was applied from the scale onto balloon 2 because we considered that to be out of our system. However, you can still see that there is an equal force acting from balloon 2 onto balloon 1 that there is acting on balloon 1 from balloon 2.
To design and then explain this experiment, we used a few main physics ideas revolving around electrical charge. First thing is that everything has a charge of either positive or negative because everything is made of charged particles. If an object is neutral, it has an equal number of protons and electrons, but there is still a charge. Next, the charges will react with one another. Like charges will repel each other and opposite charges will be attracted to one another. When dealing with charge, one can use Coulomb's law to determine the force, and this equation, Kc is the constant, Q is the charge of the specified particle, and R is the distance. As one can see, the strength of a charge of a particle and the distance between them will change the magnitude of the force that is exerted.
During this experiment, the charges of the balloons were quantified through measuring the repelling forces of the two equally charged balloons. In order to do this, the balloons were blown up to equal size and tied off. Then the balloons were simultaneously rubbed on different sections of a piece of cotton clothing, back and forth 5 times. This ensured that the balloons were charged with equal magnitude of the same sign. Balloon 2 was immediately placed on the scale and balanced at 0 grams. Then balloon 1 was timely held 5 centimeters directly above balloon 2. The increase of weight on the scale was recorded as change in weight. This was repeated 3 times with neutralizing the charges with skin contact between each trial. This data table includes the numerical data collected during the experiment, including the change in weight indication on the scale in grams, the calculated force, and the balloon charges. In order to calculate the charge of each balloon, we used the known acceleration of gravity and the change in mass of balloon 2 in order to find the force balloon 1 exerts on balloon 2 after being charged. This value of force was then used to calculate the charge of the balloons under the assumption that balloon 1 and balloon 2 have equal charges. A constant of 8.99 times 10 to the 9th was used for this experiment, with an r-hat value of 1 and a distance between the balloons of 0.05 meters.
After our data was collected, we were able to determine the charge of each balloon by using the weight and the known acceleration of gravity, as stated before. With the calculations that we used above, we averaged the 3 charges found in each trial to determine the charge of the balloons. This was 5.29 times 10 to the negative 7th coulombs. When doing the calculations and finding our results, we used physics to guide us. First, we assumed that balloon 1 and 2 are Newton's third law pairs, which means that the forces exerted on each other are equal because for every action there's an equal and opposite reaction. We also assumed the charges on the balloons were the same sign based on the observation that they repelled each other along with being charged the same way. And as explained before, we used gravity and the change in mass to determine force that was used in Coulomb's law equation.
There are many things that could have resulted in errors within our data. First of all, unequal charging of the two balloons. Also, while we aimed for a distance of 5 centimeters in between the balloons throughout all of the trials, it is hard to say that it was 5 centimeters on the dot throughout all of the trials. The scale also had many fluctuations. In addition, while we know that the charges have to be the same sign, we are unable to tell whether or not They are both positive or they are both negative. All that we know is that they repel. Thanks for watching.